Hello everyone, this subject is on basic electrical engineering and today we will discuss module 1 which is related to DC circuits and network theorems. So first of all we will discuss Ohm's law. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions remain unchanged. So basically, this law states that the current flowing through a conductor is directly proportional to the potential difference across its ends. And in other words, we can say that the current flowing through the electric circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit. What is resistance? Resistance is basically the obstruction offered in the path of current. So, this is the basic principle which is related to Ohm's law. And the mathematical equation of Ohm's law is V is equal to IR. That is, potential difference is directly proportional to current. V is directly proportional to I. And what is R? R is the proportionality constant. And in terms of electricity, we can say that R is the resistance. V is the voltage in volts. R is the resistance in ohms and I is the current in ampere. So we are having different formulation when we use this formula for doing the numericals. Voltage V is equal to IR as per the Ohm's law. What is I then? I is V by R. I is current and resistance R is equal to V by I. Now we will discuss the numerical problem related to Ohm's law. So our first problem is the electric current in a resistor wire is 4 amperes. When both the ends are given a potential of 12 volts, what is the electrical resistance? So what is given to us? We are given with the current whose value is 4 amperes and we are given with the potential difference that is 12 volts. So we are given with I and V. So what we have to find, what is the unknown component, that is R. So R is equal to V by I, that is 12 by 4, which is equal to 3 ohms. So that is the answer. Now we will move to the second problem. What does it states? In an electric circuit, current of 1.5 microamperes. So what is the value of current? 1.5 microampere. What is micro? Mathematical value of micro, that is 10 raised to power minus 6. So current is 1.5 into 10 raised to power minus 6 ampere. It is this current is grow through a resistance of 2.3 mega ohms. Now what is mega? That is 10 to the power 6. So what is the value of resistance in terms of ohms? That is 2.3 into 10 raised to power 6 ohms. Now again we will apply the Ohm's law formula, mathematical formula, that is V is equal to IR. We are having the current I, which is 1.5 into 10 raised to power minus 6 ampere, and resistance R is equal to 2.3 into 10 raised to power 6 ohm. And after multiplication we will get the value of voltage as 3.45 volts. So this is how we will do the problems which are related to Ohm's law. Now this is our next topic, that is resistance in series and parallel. So what are the basic properties of series resistances and what are the basic properties of parallel resistances? We will first discuss this and then we will move towards the numericals which is related to this concept. So series resistor properties. In the series, when the resistance are connected in series, the same amount of current flows through all the resistances. That is, I1 is equal to I2 is equal to IN. Potential difference, but the potential difference is different across each and every resistor. If we consider across first resistor, that is V1, across the second resistance, that is delta V2, and across the nth resistance it is equal to delta V1. So total voltage across the series circuit is equal to delta V1 plus delta V2 plus up to the delta Vn. This is the second property, that is current is same. First property is current is same and voltage is different, which is different across each and every resistor connected in series. The resistance with the biggest resistance has the greatest voltage. It is obvious because what is voltage? That is proportional to R. So biggest resistance will automatically have the biggest, that is the greatest voltage. Now, the equivalent resistance Rs is always more than any resistors in the series configuration because the equivalent resistance is the summation of all the resistances, that is R1 plus R2 till Rn, that is nth resistance. So these are the properties of the resistances which are connected in series. Now we will move towards the properties of the resistance which are connected in parallel with each other as shown in the diagram. So here we are having three resistances which are connected in parallel. We can have the multiple resistances which are connected in parallel. The current is distributed across resistance. Current is I1, I2, I3 till the nth resistance. And what will be the value of total current? The total current will be the summation of the current which is across the resistance 1, across the resistance 2 and across the resistance n. So I will be equal to I1 plus I2 up to IN. That is the property of parallel resistances. In parallel, current is the addition of, total current will be the addition of the current across the individual resistances while the voltage remains the same. So second property is potential difference is the same across all the resistances in parallel. Delta V1 is equal to delta V2, it is equal to delta Vn. Till the nth resistances, the potential difference will remain the same. The smallest resistance gets the most current. Why so? Because I is inversely proportional to the resistance. So greater the value of resistance, lower will be the value of current. And smaller the value of resistance, greater will be the value of current. So this is also one of the property of the resistances which are connected in parallel. The equivalent resistance Rp is always less than any resistance in the parallel configuration. Now we will consider one example. Suppose R1 is 4 ohms and R2 is 8 ohms which are connected in series. So what will be the total resistance? I have already told you it will be the summation of R1 and R2. So it will be the summation, that is 4 ohm plus 8 ohm, that is equal to 12 ohm. Taking the same values for the parallel resistances for R1 4 ohm and R2 8 ohm which are connected in parallel. So Rp will be equal to 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. That will be equal to R1 into R2 divided by the summation of the resistances, that is R1 plus R2. So net resistance will be 8 by 3 ohms, that is the parallel resistance, or we can say that it is 2.3 ohms. Voltage division in series circuit. This topic is basically to define how the voltage is divided in the series circuit and how the current, and in the next topic we will discuss how the current will be divided in the parallel circuit. So here we are having two resistances, that is R1, which is R1 ohm, and R2 ohms, and V. So what will be the total voltage? That is the voltage drop across R1 and the voltage drop across R2. So what will be the voltage drop across R1? That is I into R1, and voltage drop across R2 will be I into R2. So total voltage will be equal to IR1 plus IR2. Now what will be the value of I? That is V divided by R1 plus R2. Therefore, the total voltage applied is equal to the sum of voltage drop across V1 and V2 across V1 and V2 across R1 and R2. V1 क्या होगा? What will be the value of V1? I into R1. And what is the I? I is V by R1 by R2. ठीक है? So V by R1 by R2 into R1 will be the value of V1. That is R1 divided by R1 plus R2 into V. Similarly, what will be the value of V2? I into R2. And what is the value of I? V by R1 plus R2. So what will be the value? Equivalent value, that is R2 divided by R1 plus R2 into V. So if we take in general terms, we can say that what will be the value of voltage across R1? That is total voltage V multiplied by the opposite resistance, that is R2, divided by the total resistance, that is R1 plus R2. And what will be the value of voltage across R2? That is R2 voltage R2 divided by the total resistance R1 plus R2 into V. So in terms of voltage revision rule, the value of voltage V that is V1 across R1 is equal to total voltage V multiplied by the same resistance R1 and divided by the total resistance, that is R1 plus R2. And the voltage V2 will be equal to the same resistance, that is R2 divided by total resistance R1 plus R2 multiplied by V. This is the voltage division rule. Now this topic is current division in parallel circuit. So how do the current is divided in the parallel circuit? According as per the circuit diagram, we are having a voltage source V, and the current which is flowing through the voltage source is I. This current is distributed as I1 and I2 among two resistances, that is R1 and R2. I1 is the current across R1 and I2 is the current across R2. Now, what will be the value of total current I? It is equal to I1 plus I2. What will be the value of V? We have also already studied the property of parallel circuit. That is, in a parallel circuit, voltage remains same across all the branches. So V is equal to I1 R1. It is also equal to I2 R2. Now, what will be the value of I1? That is I2 into R2 by R1 as per the equation 2. Now, putting this value as obtained in equation 3rd in equation 1. I is equal to I2, R2 by R1, and taking the I2 as common, R2 by R1 plus 1. So, I is equal to R2 plus R1 divided by R1. Or we can say that I2 is equal to R1 divided by R1 plus R2 into I. Similarly, we can get the value of I1. Putting I1 equal to I minus I2 and substituting I2 value, we will get the I1 is equal to R2 divided by R1 plus R2 into I. So, sorry. So, as per the current division rule, in general, if we can say, in general, the current will be divided into along the parallel paths, and the current across each path will be equal to the total current I multiplied by the, suppose we are finding the current across R1. So what will be the value of current I1? I1 will be equal to total current I multiplied by the opposite resistance, that is R2, divided by the total resistance,